the leading coefficient has to be 1. If it isn't, what you're going to do is divide everything by that leading coefficient and complete the square as usual. So it's the same steps as yesterday, except we have to now incorporate step 2. And I like to flip-flop step 1 and 2. I like to divide first and then move that number. Questions? Same steps as yesterday, just have one little extra one where we have to divide. So, we want to solve this by completing the square. To get, in order to do that, we have to get rid of that 6. What do we need to do with that 6? Divide it. So we're going to divide everything by 6. That cancels. We're left with x squared plus, what's 12 divided by 6? 2. What's 48 divided by 6? And that is equal to 0. Now, it's exactly what we did yesterday. What's our first step? Based off what we did yesterday. Add 8. So we get x squared plus 2x plus your box squared equals 8 plus your box squared. So now you're going to take the new middle number. What's our new middle number? 2. And divide it in half. Cut it in half. What's half of 2? 1. Take your new middle. Divide it by 2 to get 1. That's what we're filling our box in with. And then we're going to factor. How are we going to fill in our parentheses? Yeah, 2x is here, 2 1's in the back. So we rewrite it as x plus 1 times x plus 1. And then what do we get when we do 8 plus 1 squared? 9. How am I going to rewrite x plus 1 times x plus 1? Equals 9. We need to get rid of that square. What do we need to do to get rid of that square? Square root. Square root. Square root. So we're left with x plus 1 equals, what's the square root of 9? 3. We took the square root, so what do we need in front? To get x by itself, what do we need to do with that 1? That 1 goes in front of the plus or minus sign. So we get x is equal to negative 1 plus or minus 3. Here's the thing. Can we combine negative 1 and 3? Yeah, right? There's no more radical. There's no more I. We can combine negative 1 and 3. So just like what we do with the quadratic formula, we can separate this and do negative 1 plus 3 and negative 1 minus 3. And we do that. Negative 1 plus 3 is 2. There's one of our roots. Negative 1 minus 3 is negative 4. That's another root. So sometimes, like the quadratic formula, that happens when we complete the square. So when the radical goes away, there's no more I. We just have numbers. We can keep going. When we solve this quadratic, our solution is 2 real what? Rational. Or 2 real rational numbers. Is there any other way that we could have solved this quadratic? Is there other methods we could have used? What could we have used? Quadratic formula, what else? When we get rational answers, we often ask, is it what? Factorable. So quadratic formula, we can factor. What's our third method we could have used? Use our calculators for it. What do you do right after factoring? We use your calculator. Second trace graphing. So we look at number 2. Again, we have a number in front of that x squared. What do we need to do with it? Divide it. Divide everything by 2. So we get x squared plus 16x minus 7 equals 0. Exactly what we did yesterday. What's our first step? Add 7. We take that back number, move it over. We get x squared plus 16x plus your box squared equals 7. Your box squared. Look at your new middle. What are we going to do with our new middle number? Divide it in half. Divide it by 2 to get 8. And that's what we're filling our boxes in with. And then factor. We can kind of cheat when we factor. How are we going to fill in our parentheses? X plus 8 in both. There's 2 x's here, so they separate. There's 2 8's, so they separate. So we get x plus 8 and x plus 8. Equals, what do we get when we do 7 plus 8 squared in our calculator? 71? Condense this down. How could we rewrite x plus 8 times x plus 8? And then to get rid of the square, what do we have to do on both sides? Put a root. So we left with x plus 8. We took the square root, so what sign do we need? Can we simplify radical 71? No, it's a prime number. So there's no perfect formula besides 1. So our final step, what do we need to do with that 8? Shift it over. It goes in front of that plus sign. So x is equal to negative 8 plus or minus radical 71. There we go. Could we factor this one? Based off our answer, is that one factorable? We gotta do irrational answers. Questions over there. We take a look at 3. What do we have to do with the number in front of the x squared? Divide it. We're going to divide everything, everything, by negative 4. When we do that, it cancels. We're left with x squared minus 8x plus 16 equals negative 8. Divide everything by that number. Then what's our next step? Move the 16 16 over. Yes, there's a negative 8 there. That's okay. You're just going to move that negative 16 over to be with that negative 8. So we're left with x squared minus 8x plus your box squared equals, what's negative 8 minus 16? Negative 24 plus your box squared. What do we do with that middle number? Split it in half. Divide by 2. What's negative 8 divided by 2? Negative 4. And then make your parentheses. What are our parentheses going to look like? Good. Combine on your calculator, what do we get? Rewrite that down. How can we write x minus 4 times x minus 4? Equals negative 8. And then what do we need to do? Square root. So we get x minus 4 equals, we took the square root, so what sign do we need? There's a negative, so what do we take out? And then the 8 becomes positive. Can we simplify radical 8? Yeah. What's the largest perfect square that can go into radical 8? How many times? What's the square root of 4? Can't take the square root of 2, so it stays. So we're going to rewrite this as x minus 4 equals plus or minus 2, don't forget the I, radical 2. That I is kind of attached to that radical right in front. And then our final step, what do we need to do with that negative 4? Move it over. Or add it. And when we add it, it goes right in front of that plus or minus sign. There we go. That's our answer. Is that one factorable? We have a radical and we have an I. It's definitely not factorable. Okay, last one. So we're going to see what this looks like using complete the square. And we might see how the quadratic formula could potentially be a little bit easier than using complete the square on this one. So we take a look at 4. What's our first step? Yeah, divide by that 4. We have a number in front of the x squared. So divide everything by that number. So we get x squared plus, what's 8 divided by 4? Can we divide 4 into 9 evenly? No. So just leave it. Leave it as 9 fourths. Is equal to. Can 4 go into 10 evenly? No. So just leave it. Leave it as 10 fourths. And that's okay that we have fractions. Fractions are our friends. We have to include them in our math. And it's okay. That's why we have calculators. Calculators help us deal with fractions. But it's okay. It's not that scary. What's our next step? What do we need to do with the 9 fourths? Yeah, right? If it was just a 9, you would subtract it. If it was just a 9 fourths. So we can subtract it. So we get x squared plus 2x plus our box squared equals, what's 10 fourths minus 9 fourths? 10 fourths, right? So you have 10 fourths, and you take 9 of them away, you're left with 10 fourths. look at your new middle. What do we have to do with our new middle? Divided by what? 2. What's half of 2? 1. So when we factor here, what are our parentheses going to look like? Plus 1 equals. What's 1/4 plus 1 squared? As an improper fraction. What is it? An improper fraction would be 5/4. Think, how many fourths are in 1? 4, right? So there are 4 here, 1 here, so it's 5 in total. Condense this down. How can we rewrite the x plus 1 times x plus 1 equals 5/4. What do we need to do to both sides? Square root. We get x plus 1 equals, we took the square root, so what sign do we need? Plus minus. Do we take the square root of 5? Nope. When it gets its own radical, what's the square root of 4? 2. So it doesn't have a radical. So that's just radical 5/2. Can we simplify radical 5? No, our number. So then our final step, what do we need to do with the 1? Move it over. It goes right in front of that plus or minus sign. There's our answer. Questions over there? Let's see how this looks like, and maybe it might be easier in this scenario to use the quadratic formula. Am I okay to erase? Does anyone still need to write this down? Or it goes all the way? We good? Yeah? Just so I have room. I write really big. Lots of space. Okay, so let's see how this looks when we use the quadratic formula. We should get the same answer. So let's compare. I fill out the skeleton of my quadratic formula. I go back to my quadratic. In order to use the quadratic formula, what does your quadratic have to equal? 0. So what do we have to do with that 10? Subtract it. So we get 4x squared plus 8x minus 1 equals 0. So we're looking at that purple quadratic. We get our A, our B, and our C. Okay. What is our A? 4. What is our B? 8. And what is our C? Fill in your number. B goes here and here. A goes here. C goes here. A goes there. So then x equals -8 plus or minus the radical all over 8. And then if we, what do we get underneath our radical? 80. Can we simplify once you get your radical? Can we simplify radical 80? Perfect square. What's the largest perfect square that can go into 80? 16. How many times? What's the square root of 16? Can we take the square root of 5? Nope. So radical 80 becomes 4 radical 5. Then we have to check and see if we have what? Heart. Do we have heart? Is there a number that can go into 8, 4, and 8? Yeah, what is that number? 4. So we divide all 3 of those by 4. We get -2, plus or minus 1, radical 5, all over. Okay. They don't look identically the same, but they're equally the same. Because if you think about it, what's negative 2 divided by 2? 1, right? Negative 1. But radical 5 is not divisible by 2. So the radical 5 still has the 2 in the denominator. Now are they the same? Yeah. Just with quadratic formula, this is an okay way to write your answer. But mathematically, they're equal. They just look a little different. So that might be an instance where quadratic formula is a little bit easier to use because you don't have to deal with that missing fraction when you're solving. Okay? And we'll talk about on Monday where sometimes it's really messy to use complete the square, which is not a good idea to use it. Or sometimes it's really messy to use the quadratic formula, and it might be easier to use complete the square. Okay? We'll talk about how you can kind of look at the quadratic and figure that out before you start doing all that math. But that's for Monday. Okay? Questions over that?